All right, so this time we have a non-homogeneous equation, and the question is find the appropriate form of yp. Of course, to solve this fully, it would be a nightmare. It's not for something for humans to do. You just ask the computers to do these actual calculations. But let's see, how do you find the right form? So, I mean, find out the functions, what functions to be included in yp, except that a, b, c, d, those coefficients, I don't want you to get it yet, okay? So if you have such a question, how would you set up the yp? First, you find yc by solving the quadratic characteristic equation, which is r minus 2 squared plus 1 equal to 0. R minus 2 squared is negative 1. So r minus 2 is plus minus square root of negative 1, which is I. And then if you move the negative 2 to the other side, you get r equals to 2 plus minus I. What does that mean for yc? Yc is c1 e to the 2x cosine x plus c2 e to the 2x sine x. So you have these two forms as your yc. All right, now let's try to build up our yp. Yp should have x times e to the 2x, because it's there, right? So let's put an a there. And if you differentiated this using the product rule, you're going to create another thing that looks like this, but there will be another one which x is differentiated and you just have e to the 2x, right? So that should also be included. And then you have the next function, e to the 2x cosine x. 2x cosine x. So you include that. And, let's just erase this part. All right, and then if you differentiate this, what would you get? If you differentiate cosine, you get sine, right? So you will get another one that looks like e to the 2x sine x. And then what about the sine x? You put a, b, c, d, e sine x. And then the next one should be cosine x. F cosine x. So this is what you need in order to have your functions, when you plug in into the left side, produce the right side. Okay? But then you have to check for duplication, because duplicated ones, the functions that are duplicated in the yc would just disappear when you plug into the left side, right? So do you see any duplication?
Yeah.
I see one here. I see another one here. Okay. So what do you do with those? You have to multiply by x. So for those, you want to put an x in front. So these will need to have x in front. And sometimes when you put an x there, it also duplicates something in yp. In that case, you have to multiply x to the other ones too. But right now, you don't have anything, right? So that's where you stop. Yes?
So why do you have the x e to the 2x and just the e to the 2x? The first two.
Yeah, so the thing is, if you take x e to the 2x and differentiate,
Oh, you have to different. Okay, that's the part I missed. All right,
then
thank you.
x prime e to the 2x plus x times e to the 2x prime gives you e to the 2x plus 2 times x times e to the 2x.
Right.
Okay, and then if you look at if you just had this, then you would be missing either 2x. So that should be included.
Right.
Any function that's created in the derivative should be included again.
And that's
Or the second derivative, or the third derivative. You actually have to do more.
Mhm.
So what would you get if you differentiate this again? If you differentiate this again, you will get another one of the e to the 2x, 2 times e to 2x. If you differentiate this again, you're going to carry 1 e to the 2x, another thing that's like that. And you get, but those are already in here. So if you see that the following derivatives no longer create anything new, then you stop here. There's nothing more to include. Okay. Any other questions? Yes?
So when you complete the square using your method,
Uh-huh.
for the part where you figure out how much you need to add to the certain number to get the third number,
Right.
is that -2 squared?
Right. Okay.
Is the
So
square of the half?
So to answer that, let's review complete the square because we need it for the following part of the course. It's important. You have to learn how to do it. Okay. All right. So let's try to review that. First, you want to see why these two things are same. Okay. That will make you understand how this process actually works. Okay. So try to expand this. What do you get if you expand this? R will be squared, right? And -2 will be squared. What's -2 squared? Plus 4. But then when you expand this by FOIL, these are not the only ones created from the square, right? There's something else. What's created? R times -2 times 2. So the formula is, let me write here. A plus B squared is A squared plus B squared plus twice of AB. Okay? That's the formula. If you actually do the FOIL, this is what you get. So you take R and you take -2, multiply, you get -2R, and you have to double it because of this 2. If you double it, you get what? What do you get?
-4.
-4R, right? -2 times R is -2R. Doubling it gives you -4R. Okay? And then you have plus 1. And now 4 and 1 is added together, so what do you get? R squared minus 4R plus 5, which is exactly the same as this one.
Okay.
Okay? So once you're convinced that what I write here is indeed same as the previous one, then you try to think about how you can go the opposite way. We went from here to there, but our real goal is to go from here to there. Okay? So let's see how that can be worked. The first one you do is, you take this number -4 and divide it by 2, just like this, and you place it inside the square. And you ask the following question. I know that if you expand this, R squared will create R squared, as you see there. And also if you double the product, R times -2 is -2R. If you double it, it's -4R. That's no question, right? But then if you square the -2, you get 4, not 5. So there's a discrepancy here. So there must be something added to the previous one in order to match with this 5. So the question you ask is, what should I ask? What should I add so that -2 squared plus this number is same as that number? That's how you think, okay? But -2 squared is 4. 4 plus what is 5? 1. So that's how you get this 1. And that's how you do the completeness square. Okay? There are some other methods that people use, but I find this to be the most straightforward. Yes?
You can use a quadratic formula too, right?
You can also use the quadratic formula to find a solution, but in case when R squared has coefficient 1. By the way, this method only works when R squared has coefficient 1. If it's not coefficient 1, then it's a lot harder. Okay? That's why usually completed square throws off a lot of people in pre-calculus, and this seems to be way easier than what we've seen in pre-calculus. The full version is a lot harder, okay? But hopefully we don't have to do the full version. Okay? So we're only doing this case when R squared has coefficient 1, and if you have this coefficient of R as an even number, then completing the square is much faster than trying to solve it by using the quadratic formula. So you should try to do it this way. Any other questions? Yes?
Shouldn't it be minus bx e to 2x ln x? Cosine is negative sine.
Right. So if you differentiate cosine, you get negative sine, right? But the thing is, whether you have d times negative x e to the 2x sine x or positive, it doesn't matter because d is just some arbitrary constant to be determined later.
Okay.
So if you had this as negative d, it doesn't matter. At the end of the day, I mean, you're supposed to have it set up like this, and you're supposed to differentiate once, twice, and plug into the left side to match with the right side. That's what should be done at the end of the day. So if you had some other numbers here, like negative in front, I saw some people putting 7 here because it had 7. I mean, I wouldn't recommend having those because all those numbers could be absorbed absorbed in these E and F and all these undetermined coefficients, so you don't need them. But even if you had them, it wouldn't be wrong. You can have them. It's just not a good practice. You shouldn't do that. Okay. And yes.
Was this problem one?
Yeah.
Yeah, we did. Yeah. This was the first question. Any other question? Yeah.